Hey, I'm Chris Matthieu from RealSense. I'm with my new friend Chris Bersch from Cartken. Hey, Chris, how are you?
I'm great. Nice meeting you, and thank you for having me.
Yeah, well, you were with us at the Automate booth, and I just absolutely fell in love with your mobile AMR type cart technologies in our booth, and everyone kept coming over to talk to you guys. And as the universe would have it, you're like 13 minutes from my house, your R&D shop. So I'm super excited that you invited me down here to talk to you today.
Yeah, pleasure to have you and show us like where the robots are being developed.
I love him. Hey, so tell us about yourself and Cartken.
Yeah, so I started my career actually in robotics back in 2008. I worked for Bersch Research in Palo Alto on humanoids and self-driving cars, and that's where I really get excited about robots. But it was like very much researchy, so I took a little bit of a break on it and went to Google. Was there for 8 years working on Google Maps and search.
Wow.
But the thing about robots did not let me go, so I convinced some people at Google to give me a project, and I did an actual internal startup at Google where we looked into delivery robots. At some point we decided we wanted to do this our own, so me and some other people from Google banded together and founded Cartken. That was about 5 years ago. And since then we have been developing our technology, which is lighterless, works indoors and outdoors, and has a bunch of different use cases as it turns out. And so, initially we've been mostly focused on last mile delivery, but what we have found is like actually a really interesting market, and where these newer robots that are targeted at is industrial or sites or corporate campuses where these robots do building to building delivery. So that's where, well, previously people pushed little utility carts or carried something or moved things on a single pallet with like a small pallet jack. Like we can automate this now, and it's a new generation of robotics and autonomous systems. So it's AI based and camera based. So we can handle with that, indoor and outdoor, different weather. They run it day and night, and you don't need to instrument much because these robots can now navigate and know their way around the world without a bunch of QR markers and magnet rails or where you had it.
They're amazing. I mean, I saw at the Automate show you had a cart.
Yeah.
And then this guy actually can hold quite a bit of weight. How much weight can this guy hold?
This one can carry 300 kilogram or 660 pounds, I think.
That's crazy. And then I saw you've got like the student campus delivery vehicles too. Carriers? Is that
that's the courier, yeah.
Couriers.
So, that's the smaller one. Delivers mostly food or convenience store items in most places. These are actually running in Tokyo and in Osaka, and like the most busy areas, as well as the University of Arizona. And that's also where we test a lot of our technology out. And it works really well. And it's like we took that learning and the AI models we trained in those environments, which are tough environments, and now bringing these to other settings and other industries. Yeah.
That's amazing. Why the name Cartken?
It comes from cart, like a shopping cart, and it's like I think it's technically Dutch, not German, but it's like means small, the can. So it's just a small cart that can move things around, and with us, it moves around autonomously.
That's awesome. Yeah. Well, and you seem to be getting a little bit bigger than carts, and I absolutely think this is brilliant. And I can't help but notice RealSense cameras right in the front of this guy. Tell us about what you're doing with the RealSense cameras.
Yeah, so the RealSense cameras are a core component of our vision-based navigation system. So we use the RealSense stereo cameras as well as RGB HDR cameras for navigation. The RealSenses are really great, and as they give you like within like 5 to 10 meters. Very good features, three-dimensional features, which are part of our localization algorithm and also obstacle detection. So they're core piece of of the system.
Wow. Did you guys write your own like VSLAM, your localization?
Yeah, this is basically our core
Wow.
magic that makes these run. It's like a very advanced visual SLAM that uses multiple feature types, both mono and stereo, and can uses semantic features, uses three-dimensional features. And that is really what makes it robust in different environments and lets us deploy it very quickly, also to new factories or new sites.
Well, yeah, once you've got the basics, blocking and tackling, seems like you could do any type of AMR that a use case calls for.
Yeah, actually, so we're the way the system is architected is it's very flexible, so we can put it on different size robots, which we have done. Like you've seen the small food delivery robot and the little bit bigger cart, and now this one is currently the biggest. We're actually working on something that's even bigger, and it's all the same system. It's the same sensing and compute system, just parameterized differently, so the system knows how big the vehicle is and what the drivetrain is, because you may also notice there are some differences there, and so we can port this to different hardware bases.
Awesome. So why RealSense? Why did you select the RealSense cameras to go in your stack?
So the RealSenses are great because they do all the computation on the device, so we can offload this from the host computer. And they do a really good job in stereo matching and giving a 3D images in different environments. Be it indoors or outdoors, they don't need, they can work with light projector, but also without it. And we have actually worked quite a bit to make these robust or more robust also for outdoor environments. And these ones are actually not the standard cameras from RealSense, but like they're the modules that we packaged in a gas-tied manner with certain additions to make them really work outdoors. They also use FACRA connectors and GSML, like an automotive standard. So these are not just USB cameras. Turns out USB doesn't last very long if you go over rubble and outdoors. And so that really allowed us to build and operate these robots at a really high reliability. And that's really the core. And I just want to mention is like one part of that is the approach Intel took was very open. So it's like the drivers are open source, like very collaborative, and like, how we can evolve the technology to fit the specific use case. And so that's what made this really work and got us to the level of robustness and reliability that we need for, in particular, in industrial settings where like this just has to work.
Well, that is geeky cool. And I'd love to do a follow-up podcast where we dive deeper into what you're doing with FACRA and GMSL around the modules, the RealSense modules. That's pretty awesome. So you mentioned different types of robots on the platform. What's next? What are you thinking about? Any super secret, cool things coming up?
I want to say that much. It's like this has 300 kilogram payloads. We're going way bigger than that now.
Like a Megazoid? What are you doing?
But we'll be able to move pallets pretty soon, which is like a very common use cases in the environments we have encountered. But still the same navigation system that's been proven. And yeah, stay tuned for bigger and larger things from Cartken.
I can't wait. Well, Chris, thank you so much. I wish you all the success in the world. I love what you guys are doing. I love, obviously, that you're using RealSense, and we're going to geek out. We're going to do a deeper dive on the tech behind the modules and what you're doing there, if you don't mind, in the future.
Yeah, would love to.
Awesome. Hey, thank you very much, Chris.
Thank you, Chris.
Awesome. That was fun.